So, a useful way of adding a single carbon is carbonylation, which introduces a carbonyl group or carbonyl group, and usually that's done using carbon monoxide, which, although toxic, is a cheaply available gas. And palladium does this chemistry very well. We've already seen this type of intermediate occurring in things like the Heck reaction and the Suzuki coupling. You can generate it in a similar way from either a palladium-2 or a palladium-0 complex. And that will absorb carbon monoxide and give you this type of carbon monoxide complex called a carbonyl complex. This will then transfer to the R group, insert between the palladium and the R, and give you an acyl palladium complex. That acyl palladium can easily react with an alcohol to generate an ester, which is a pretty useful product. And notice that we started with just an R group, but we now have an extra carbon on the chain. And you'll also generate a palladium-0 complex. So an example of this would be something like this. If we run the reaction in N-butanol, that will react with the acyl palladium complex as it forms and give us the ester product. So that's a pretty useful type of carbonylation. Works best with sp2 halides. So this is kind of equivalent to what we learned in sophomore organic, where we did carboxylation of organometallics, and that was putting CO2 with a Grignard reagent or an organolithium, such as. So this reaction adds a carbon as well and generates a carboxylic acid rather than an ester, but you can see it's in many ways equivalent, at least in terms of carbon-carbon bond construction, to the carbonylation reaction we saw with palladium. It is of course limited because this R group cannot contain any reactive groups like nitro, say, that might react with when you're trying to form the Grignard reagent or react with the Grignard once it's formed. So in fact, the palladium chemistry is more versatile in some ways. Remember that both start with an alkyl halide, and so we start with this alkyl halide to make this, just like with the palladium we started with the halide there. Now, those are pretty popular methods. There's another method which is using boranes. Now, this one can work well with sp3 or simple alkyl halides. And the nice thing is you can transfer 1, 2, or 3 groups. So somewhat limited because boranes aren't always easy to make such complex boranes as that. You can do hydroboration to make them, but they are flammable in air often and easily oxidized, so that can be a bit of a limitation. But if you have this accessible, you can Either put in one carbon monoxide in the presence of lithium aluminium hydride, and for that we inserted one carbon monoxide and we got a simple alcohol with one more carbon in the sequence. Comes out in this reduced form because we've used a strong reducing agent. And we do a workup with boranes. We usually do a workup with hydroxide and hydrogen peroxide. If we do similar chemistry, we get a second one transferring, in that case we get to a ketone. Now what if you want to do all three of these, transfer all three R groups, then if you heat it in presence of, I believe you heat it in the presence of ethylene glycol, you get. Okay, so in this case with the ethylene glycol we transfer all three R groups onto the carbon monoxide and that gives us a tertiary alcohol. And if we do it with in the presence of water, it stops at 2, we only transfer 2 R groups and we get the ketone instead. And then if we do it in the presence of lithium aluminium hydride, only one R group is transferred onto the carbon monoxide. And that gives us then this primary alcohol. So depending on what your needs are, you can manipulate the conditions to transfer 1, 2, or 3 R groups. But of course, you have to be careful that the R group that transfers is the one you want. And there are rules on that. But I don't want to get into all that now, so I'll stop there.